Okay, good evening. Welcome to Continued Fractions, Part 2. So yesterday, what one is this? Is this Math for Kids 16, I think?
17.
17, okay. So yesterday we learned what a continued fraction was, or actually technically I guess a simple continued fraction. So it was like 2 plus 1 over 4 plus 1 over 2 plus 1 over 3, like that.
Etc., etc.
Etc. And we learned how to turn this continued fraction into a regular fraction.
And we learned that continued fractions can go on forever.
We learned that continued fractions can go on forever. So, it turns out to be a little tricky to evaluate this, so we're going to learn a little bit how to do that today, a better way on how to do it. Okay?
Yep.
You're erasing the board with your shoulder? Okay, here we go. So we're going to write down the simplest continued fraction that we can possibly imagine. All ones. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. How about we can keep it going on forever if you want. And we're going to try to evaluate this. Okay?
Actually, just put a 1 here. That's fine.
Okay, you don't want to have it evaluate it forever. But you know what? On this one, you're actually probably going to be able to figure out how to evaluate it forever. This is a special continued fraction. So what we're going to do is we're going to first look at just 1, just this part. Then we're going to look at 1 plus 1 over 1. Then we're going to look at 1 plus 1 over 1 plus 1 over 1. And we're going to see if we see any patterns, okay? Mm-hmm. All right? So here we go. I don't know where I'm going to write the pattern. So the first thing we look at, I'll write it here, is just 1. Okay, so this is the simplest continued fraction of all. What is that equal to? 1. Very good. 1. Okay? Here's the next continued fraction. 1 plus 1 over 1.
Which is the same as the 1 over 1.
What is that?
1 over 1 is just 1.
1 over 1 is just 1. So what is this equal to?
This is equal to 1 plus 1.
Which equals 2. Okay, so write 2. And then say that equals 2. Okay, well, this is an interesting pattern. Let's see what's next. 1 plus 1 over 1 plus 1 over 1. All right, let's see if you can evaluate that.
So 1 plus 1 over 1, that's 2. And 1 over 1 is 1, so this is 1 plus 1 plus 1.
Oh, no, 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 no. This is definitely not 1 plus 1 plus 1. Here, stand over here a little bit.
Okay.
So, in order to evaluate this, we have to evaluate the bottom part of this fraction first. Remember, you evaluate continued fractions up the ladder like that. Okay? So this is equal to, well, what's this 1 over 1 equal to right here?
1.
So what's the bottom of this fraction equal to?
1 plus 1.
1 plus 1 over 2. Right?
Yeah.
1 plus 1 on the bottom. And what is 1 plus 1 half? Do you remember?
1 and 1 half.
Okay, which we normally write, or which we can write as 3 halves. Okay, so good. So number 3.
I better move.
Yeah, you better move. 3 halves. Sorry we don't have more places to write. Okay, so we get 1, 2, then we get 3 halves. Let's see what comes next. You ready? 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. Woo! Okay, so we got to evaluate the bottom of this first. So this is equal to 1 plus 1 over 1 plus 1 over 1 plus 1, which is 2.
Yep.
Okay? And on the bottom here we have 1 plus 1 half, which we already said was 3 halves, right? Okay? Watch out, honey. Okay, and what is 1 plus 1 over 3 halves equal to?
Well, 1 over
plus 1 over 3 halves equals...
It's 1 plus 2 thirds.
1 plus 2 thirds. And how many thirds is 1 plus 2 thirds?
5 thirds.
5 thirds. Very
I can
good.
draw that with pies.
You can draw it with pies? Or how did you figure out that it was 5 thirds?
Well,
So
because
quick.
1 is 3 thirds.
1 is 3 thirds. Very good. So we get 1, 2, 3 halves, 5 thirds. Let's see what comes next. Okay?
Yep.
You ready?
Yep.
All right.
Let's see.
Whoa, I hope I write this down right. So 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1. I think that's the one we're on now, right? Okay, so 1 plus 1 over 1. What does that equal to? Here I'm just going to have to use the eraser a lot. 1 plus 1 over 1 equals?
Equals 2.
2, right? That's 2. What does 1 plus 1 half equal?
Equals 3 halves, what you got out there.
3 halves. What is 1 over 3 halves?
It's 5 thirds.
No, 1 over 3 halves.
That's 2 thirds.
2 thirds. What is 1 plus 2 thirds?
5 thirds.
So this is 5 thirds on the bottom. And what is 1 over 5 thirds?
That's 1 plus 3 fifths.
1 plus 3 fifths, which is just?
So it's just 8 fifths.
8 fifths, very good. Wow, you're starting to understand fractions pretty well. Maybe continued fractions is a great way to teach fractions.
Maybe.
Maybe, who knows? That'd be kind of
Continued
funny.
fractions are regular fractions.
Yeah, they're a crazy kind of regular fraction. So next we get 8 fifths. Okay, so let's take a look at our numbers we have here. I'm going to write them all as fractions. So I'm going to write the first one, 1, 2, 3, 4, 5. Let's see if we can guess what 6 is. But I'm going to write it as a fraction. So 1, I'm just going to write 1 over 1. Then I'm going to write 2 over 1. 3 over 2.
5 over 3.
5 over 3.
And 8 over 5.
8 over 5. Okay, so we have
I see something.
What do you see?
I see that, well, here, this number increases by 2 to get to this number.
Okay.
And then this number increases by 3 to get to this number. This number increases by 1 to get to this number. And this number increases by 2 to get to this number.
Oh, that's interesting. Okay.
So
here, look on the top of the fractions we have the pattern 1, 2, 3, 5, 8, and on the bottom we have the pattern 1, 1, 2, 3, 5. So what would you guess the next number is going to be down here?
I guess.
What do you think the next number is going to be on the bottom?
This is going to. I think this is.
Yeah, on the bottom of the fraction. Look at what the numbers are on the bottom of the fraction. 1, 2, 3, 5. Do you see 1, 2, 3, 5 anywhere else? Anywhere else over here?
Here?
Yeah. Okay, you see it up there? This is the top, and this is the bottom. Okay, so 1, 2, 3, 5, 8. And here we got 1, 2, 3, 5. So what do you think will be next?
8.
8, okay. What do you think will be next up here? This is the tricky one.
So this increases by 2, this increases by 3. I think it's going to increase by 4. I think it's going to be 12 eighths.
You think it's going to increase by 4. Okay, so let's see what they increase by. The increase here is 1, then 2, then 3. Do we see 1, 1, 2, 3 anywhere? 1, 1, 2, 3. So what was the next? What do you think the next increase is going to be?
5.
5. So that's going to be 8 plus 5 is
13.
13 over 8. Okay, and then if that pattern held, the 13 would go to the bottom, and then we would have 8 more on top, so we would get what?
21.
21 over 13. These numbers ring a bell? Have you ever seen these numbers before? 1, 1, 2, 3, 5, 8, 13?
Fibonacci!
It's the Fibonacci numbers.
The Fibonacci numbers are like hidden in the
How did-
continued fractions.
How did we find the Fibonacci numbers? Isn't that crazy? We found the Fibonacci numbers just by writing down the continued fraction 1 plus 1 over 1 plus 1 over 1 plus 1 over...
I'm going to write fib.
The fib numbers? The fib numbers might be something a little bit different. You know what fib means?
Lie.
The lie numbers. Okay, so we found the Fibonacci numbers. Can you believe that? we found the Fibonacci numbers hiding inside of this really simple continued fraction. And that's why I said we'd be able to figure this out going on forever. Isn't that pretty amazing?
Yeah, because the 1 plus 1 over 1 plus 1 over 1 plus 1 over 1, that's just it's going to continue to be the fibs.
It's the Fibonacci numbers. So the Fibonacci numbers come out of this very simple sequence for this continued fraction.
Yeah.
So basically the easiest continued fraction you can think of
Has the Fibonacci.
has the Fibonacci numbers hiding inside of it. Can you believe that? Okay, so tomorrow, I was going to do it today, but we're kind of running up against our 10 minutes. So tomorrow I'm going to show you an easier way to evaluate the first little parts of the continued fraction, which are called the convergence. Okay, so tomorrow you're going to learn about that. Wasn't that pretty neat today?
Yeah.
Can you believe you saw the Fibonacci numbers in there?
Whoa.
Whoa. I can't believe it. All right, good job.